Good morning everyone. So in this lecture I am going to give some introduction about network theory subject networks. So for GATE 2018. Now first we will discuss about the syllabus. So what is the syllabus we need to cover for GATE 2000 GATE exam. So the first topic is network solution methods, nodal and mesh analysis, right? And the network theorems. So we need to cover superposition, Thevenin's and Norton's, maximum power transfer. Similarly, Y delta transformation, or we can say star to delta transformation. Next, steady state sinusoidal analysis using phasors, right? Next, time domain analysis of simple linear circuits. So this concept is generally, we can say, transient concepts, right? Next one is solution of network equations using Laplace transform. So suppose some network is given, how to find responses, so using Laplace transform. So very easy topic this one. Similarly, frequency domain analysis of RLC circuits. So this is generally the resonance concept, so we'll get questions from these concepts also. Next one is two-port network parameters, driving point and transfer function. So we will not get questions from this concept, but once we know how to find the transfer functions or driving point impedances, admittances, sometimes we may get. So otherwise, so this will be very helpful for when we study the analog electronics. So how to find the transfer functions. Similarly, the control systems also. So that's why we need to study this one also. The last one is state equations for networks. So this concept is also there in control systems. So there we will study in-depth state space analysis. So I don't think so it is necessary when we discuss about network theory, right? Apart from this, first we will start with the basics actually. So basics means what is the power, energy for different elements. Similarly, how to find R equivalents for a given only resistance networks, right? Because we will get sometimes questions from basics also. But before that, what are the textbooks we need to follow for this network theory? So I thank all the professors who done a great job, right? So that is first textbook is then it is standard textbook for network analysis. So network analysis by M.E. van Valkenburg. The second one is fundamentals of electric circuits by Alexander and Sardiku. The third book is engineering circuit analysis by Hatt and Kimmerly, right? So I will follow these three books so to give knowledge, right? So on so many problems we have to do. If you follow these textbooks and if you practice very well from these textbooks, so you will get 100% marks, right? There is no doubt. So that we will see later. Now, so what is the in GATE 2017? How many marks we got in each topic? So nodal analysis, mesh analysis, sometimes we may get, sometimes we may not, but that will be helpful when we solve these problems also. So network theorems. So from the Thevenin's theorem and Norton theorem. So combinedly we got one question, that is in set 2, one question for 2 marks. So finding the R equivalent or Thevenin equivalent of a given circuit. So we got one question for 2 marks, that is in Thevenin's theorem or Norton theorem combinedly. So that is about that one. Next, steady state sinusoidal analysis using phasors. So we got this time in set 1 2 questions we got, that is 1 mark question 1 and 2 marks question 1. So totally we got 3 marks in set 1 itself only, right? Next one in the transient analysis, set 1 and set 2 we got only one question, so for 2 marks, right? And solutions Laplace transform is not used, or we can say we will not get any question from this, because in RLC circuit or transient concept sometimes we will use Laplace transform concept, so it will be included in this, right? So separately we cannot get the question from this concept. But in frequency domain analysis of RLC circuit, I told you the resonance concept. So in set 2 we got one question for 1 mark, right? Remaining we did not get any questions. So if you take one more question, that is the basics, also finding the R equivalents, so maximum and minimum resistances finding. So in set 1 is given for 1, so it is not on set 1, it is in set 2 for 1 mark. So combinedly in set 1 and set 2. So for network theory we got 1, 3 and 3, 6 marks from the set 2. From set 1, 5 marks. So we got from the network theory, right? So this time he did not ask about the two-port or network parameters. So but we are expecting in GATE 2018. So he will touch two-port parameters. Anyway, we have to complete all the syllabus point wise, right? Problems wise, everything we will cover. So this is about the introduction to the network theory. In the next lecture we'll start the basics of the networks. So what are the basics required to study these concepts, right?